everyone, welcome to part 3 of our lecture on chapter 6. Today we are going to cover covalent bonding. Thus far we've covered ionic bonding, which is the transfer of electrons from a metal to a nonmetal. And this makes a metal cation and a nonmetal anion. And that difference in charge, that positive and negative, that's what forms the ionic bond. Now, a covalent bond is different. Covalent bonds are formed by sharing electrons. And so if you'll see, on this nonmetal, we have 7 valence electrons, and on this nonmetal, we have 7 valence electrons. But when they share those electrons, then they each can complete their octet. So the nonmetal on the left has 1, 2, 3, 4, 5, 6, 7, 8, and the nonmetal on the right has 1, 2, 3, 4, 5, 6, 7, 8. So by sharing those electrons, they each have an octet, and that sharing of an electrons is called a covalent bond. Ionic bonds are made between metals and nonmetals, and covalent bonds will be made between two nonmetals. So that's what we'll be covering today, covalent bonding. So when we have two nonmetals that are bonded through that covalent bond, we call it a molecular compound. Sometimes you'll hear it called a covalent compound. That's not necessarily wrong. It's just more correct to call it a molecular compound. It's held together by covalent bonds. So in these covalent bonds, those valence electrons are being shared rather than in ionic bonds when they're being transferred, right? In ionic, we have it going from a metal to a nonmetal so that they each get their own octet. And in a covalent bond, they're sharing to make that octet. So when we have two or more atoms that are sharing electrons, they form a molecule. So here it is again, that slide that I was showing on the beginning, right? We have those two nonmetals, each with 7 valence electrons. And here they are going to share those electrons, and they're going to form a covalent bond. We are going to look more at this when we get into molecular shapes in a later chapter and drawing Lewis structures. But for now, what I want you to know about covalent bonds is that those electrons are being shared in order to get an octet. So in a hydrogen molecule, hydrogen actually does not follow the octet rule. Hydrogen follows the duet rule because it's trying to be like helium. And helium has 2 valence electrons to complete its, quote unquote, octet, but it's a duet. So hydrogen, right? Hydrogen is trying to fill up that 1s orbital. And that 1s orbital will be full when there are 2 electrons in it. So normally hydrogen only has 1 valence electron, so it will share it with another hydrogen atom, and when they share, then together they each get 2. So this hydrogen, the hydrogen on the left gets 2, and the hydrogen on the right gets 2. Okay, so now they will each become like that nearest noble gas, which is helium. So here's some more examples. So if we have fluorine, fluorine has 7 valence electrons each, but when they share, right, they're sharing these 2. Each one of them shares 1 electron, right? So this fluorine will share this electron, this fluorine will share this electron, and when they share them, now the fluorine on the left has 1, 2, 3, 4, 5, 6, 7, 8, and the fluorine on the right has 1, 2, 3, 4, 5, 6, 7, 8. Similarly, we have water happening down here on the bottom. Oxygen has 6 valence electrons, so it actually needs to share 2, right? It's going to share 1 from this hydrogen and 1 from this hydrogen. So now the oxygen has 1, 2, 3, 4, 5, 6, 7, 8, and each hydrogen has 2. Like I said, hydrogen tries to follow that duet rule. So again, this is just to show you that these nonmetals will share their electrons in order to get an octet, or in the case of hydrogen, to get a duet. But again, more on how they share them when we get into Lewis structures and molecular shapes. So we're going to learn how to name them now. In molecular compounds, right, when things are covalently bonded, we are going to use prefixes to indicate the number of nonmetals. If you'll recall, when we started talking about ionic bonding, I said, don't worry about what the numbers on the bottom are when we're trying to name things, because they don't matter. We're just going to name it aluminum oxide or calcium chloride, right? We're not going to use any kind of prefixes, and we're not going to say anything about, how many of each atom there are, because we figure out how many of each atom there are based on their charges. So molecular compounds follow different rules, though. They can actually share their electrons kind of differently. And so we will use prefixes to tell us how many of each atom is in this molecule. So a couple of rules. The first rule with these prefixes is don't use mono for the first one. So if we only have one of the first one, we're just going to name it nitrogen or whatever the case may be. We're not going to use a prefix if there's just one of the first atom. We are always, though, going to use a prefix with the second atom, and we're going to use a prefix for the first atom anytime there's not just one. So say there were 2, or 3, or 4 of the first atom. Then you would use a prefix. The only time you won't is if there's just one, and it would be mono. This will make more sense as we go forward. And then the second one is, is a rule. It's a good one. But if you don't remember it, that's actually okay. I won't be too finicky about this one. But this would be carbon, right? So we don't say monocarbon for the first one. We would just say carbon, and then there's one oxygen. So rather than saying monooxide, we say monoxide. So we drop, right? Like if we look at this would be monooxide. And we drop the first vowel. So we're going to drop this one, and this just becomes monoxide. But again, I won't be too strict on that in this class. That's just more to help you if you go on to higher levels of chemistry. This one, though, you need to know, do not use mono for the first one. So let's see. Here's our prefixes. So these should look kind of familiar, especially if you've taken some math classes like geometry. These are the same prefixes that you would use, like an octagon or a hexagon, right? They're the same. The ones you might not be familiar with are maybe the first couple, but I do need you to memorize these prefixes. Okay, I know you probably feel like, man, we have to memorize all these things lately, but yes, you do need to know the prefixes as well. But like I said, you should be familiar with at least a few of them from math. So here's some examples. We have, like carbon, and then there's 2 oxygens, so we call this dioxide to tell us that there are 2 oxygens. And then carbon disulfide to tell us that there's 2 sulfurs. Sulfur dioxide to tell us there's 2 oxygens. Sulfur hexafluoride to tell us there's 6 fluorides. And then sulfur trioxide to tell us that there are 3 oxygens, right? So that's a little bit, or a couple examples. We're going to see some more in a minute on how these names tell us about the formula. These are ones that you might find, out in the world. Carbon dioxide, right? Dry ice. Everyone loves dry ice. It's also in fire extinguishers or in, your soda. But there's lots of different uses. And so, again, now when you look at, a soda can or, anything that you're buying, this will help you interpret what, atoms and molecules are actually in the stuff that you're buying. So let's try these. What's the formula? So here we have some names, and we need to be able to write the formulas. And again, this is actually going to be easier than ionic bonding, because in ionic bonding, we needed to do that whole circle and switch, right? Figure out the ions, circle and switch them to get, the ratios so that the, positives and negatives cancel out and be neutral. This is not like that. We're just going to use the prefixes to tell us how much of each one there are. So diphosphorus tells us that there are 2 phosphorus. And trisulfide tells us that there are 3 sulfurs. And that's it. So you're just going to use the prefixes to tell you how many of each atom you have. So nitrogen does not have a prefix, so that means there's just 1, because remember, we're not going to use mono with that first element. And then dioxide tells that there's 2 oxygens, so O2. Phosphorus, there's no prefix, so there's just 1 of them. And then pentafluoride tells us that there are 5 fluorines. Nitrogen, so no prefix, tells us just 1. And then monoxide, so, right, remember monooxide, monoxide? So that tells us there's 1 oxygen. And then silicon, no prefix, so there's just 1. And then hexachloride tells us that there are 6 chlorines. So like I said, pretty straightforward. You're just going to use those prefixes to tell you how many of each atom you have. So go ahead and pause here and complete problem 22 in your lecture worksheet. Once you're done, come back and we'll keep going. Okay, now we're going to do the opposite. We're going to take our formula and we are going to name it. But again, we're going to use those prefixes. So it's not too tricky. You just need to know, the prefixes. So again, we're not going to use mono with the first one. So we're just going to write nitrogen. And then there are 2 oxygens. So that is dioxide. The next one, there's just one, of our silicon. So we'll write silicon, no prefix. And then there are 4 of our fluorines. So we'll write tetrafluoride. Okay, and then now there's 2 nitrogens here. So we do need a prefix because there's more than one. So this will be dinitrogen. And then there are 6 fluorines. So that's hexafluoride. Just 1 carbon, so no prefix, so we write carbon. 4 bromines is tetrabromide. And then just 1 nitrogen, so no prefix, nitrogen. And then 3 chlorines gets us trichloride. So there you go. As long as you know the prefixes, right, you can write the names of all of these compounds, but you need to know the prefixes. And again, don't use mono with the first one. Okay, go ahead and pause here and complete problem 23 in your lecture worksheet. Once you're done, come back and we will keep going. Okay, our last topic in this chapter is to figure out, how do we tell if something is ionic or molecular, right? Because that dictates the name. So the first step would be to figure out, okay, am I naming it in an ionic fashion or a molecular fashion? So the first step would be, is there a metal, right? If there is a metal, then that metal is always going to be in the front, and that metal will tell you that it's ionic. Okay, so that's a really good way to look. See, the first element, if it's a metal, it's ionic. If there's 2 nonmetals, then it's molecular. Okay, the ionic will always be a metal and a nonmetal, but as you can see, it's always going to have a nonmetal for the second one. So the metal is the thing that's really telling us that it's ionic. Then we're going to name it, 2 different ways. So the metal, right? Sometimes it could be ammonium. Remember, ammonium is our 1 polyatomic that's a cation. But that's kind of rare, so mostly it's going to be a metal. The metal can either form 1 or 2 positive ions, right? It's always going to be a cation. Remember, cations are positive because cats have paws. So if our metal only forms 1 positive ion, then you're just going to use the name of the element. So like calcium or aluminum. If it can form more than 1 ion, and that would be our transition metals. Okay, then you're going to use a Roman numeral to tell us what the charge is. Is it copper 1 or is it copper 2, right? So that would be how we would name that. If it's, and for the second one, the nonmetal, if it's just an element, like it's a sulfur or it's an oxygen, right? That's what a monatomic ion means. Then you're going to use the first syllable of the element followed by IDE, so like oxide or sulfide. And if it's a polyatomic ion, then you're just going to use the name of the polyatomic ion. Okay, so this would be for ionic, right? A metal and a nonmetal. If it's molecular, that's what we were talking about last time, or this time, sorry. Our first nonmetal, we will use a prefix, except, right, don't use mono. And then the rest of the name doesn't change. So it will stay the same, like nitrogen or sulfur. And the second nonmetal, we will change to end in IDE, but for both of these, right, the key is that there's going to be a prefix. That's what's important here. Molecular uses prefixes. Ionic does not. That's kind of the really big distinguishing factor here. Okay, so this flow chart will help you kind of organize your thinking and figure out, is it ionic and do I name it that way, or is it molecular and do I name it that way? So let's go ahead and try this out. So the first one, we have boron and fluorine. So boron, right, is a nonmetal, and fluorine is a nonmetal as well. So this is 2 nonmetals bonded together. So that means that this is going to be molecular, right? This is covalent bonding. And so when we have molecular or covalent bonding, now we name it using prefixes. Okay, so this will be boron. And then, right, because there's only 1 of the first element, we don't include mono. And this will be trifluoride to show us that there are 3 fluorines. Down to the next one. So we have oxygen and chlorine. These are both nonmetals. So again, this is molecular or covalent, right? And we are going to use prefixes. So this will be oxygen, right? Because we don't use mono with that first element, and then it's going to be dichloride because there are 2 chlorines. But again, both of those are molecular, so we need to use our prefixes. So now we have aluminum and oxygen. So aluminum is a metal, therefore this is ionic. Okay, so we will not use prefixes. So we will just name this, right? It doesn't matter what the numbers on the bottom are now when it's ionic, so we will just name this as aluminum oxide. Okay, so the numbers on the bottom only matter when we're trying to figure out the name of our covalent or our molecular molecules, right? They don't matter for our ionic compounds. For the last one, we have nickel in the front, right? And then we have this polyatomic here. This is phosphate, okay? What's important in this one is that nickel is one of those transition metals, okay? So we know it's ionic because nickel's a metal and it has a transition metal. So remember, transition metals mean that we need to include the Roman numerals. So the way that we would do this is we would kind of uncircle and switch, if you remember. This 3 came from the phosphate because phosphate is PO4 3-. And there's nothing out here on the phosphate, right? The phosphate is not in parentheses and there's nothing out there. That means that nothing essentially came from nickel. And the reason that there would be nothing is that's because nickel is a 1+. Remember, we don't carry 1s. So that means that this is nickel 1 phosphate. Okay, so we needed to include our Roman numeral here because nickel is a transition metal, and we needed to figure out what the charge of that nickel is. Okay, so those ones are the trickiest. So now we're going to do it the opposite. We're going to write the formula for each one of these. But again, we need to figure out, is this ionic or is this molecular? So we have aluminum chloride. Aluminum is a metal and chlorine is a nonmetal. So that means that this is ionic. Okay, and so whenever it's ionic, I want you to think circle and switch. Okay. So whenever it's ionic, think circle and switch. So now we need to figure out the charges of these ions. So aluminum, if we look at aluminum on the periodic table, aluminum has 3 valence electrons, which means that it's going to lose those 3 valence electrons so that it has a complete shell, right, a complete octet underneath. So aluminum is going to form Al3+. Chlorine has 7 valence electrons, so the way that it will get to an octet is it's going to gain 1. So it will form Cl-. So we have Al3+ and Cl-, so we're going to circle and switch. The 3 is going to go to the chlorine, and the 1 is going to go to the aluminum. And so we will get Al, and there's no, imaginary 1 here, and then Cl3 from that aluminum. The next one, we have phosphorus pentabromide. So there's 2 different ways you can figure this one out. We can look at phosphorus. Phosphorus is a nonmetal, right? And bromine is a nonmetal. So that means 2 nonmetals. This is going to be a covalently bonded molecule. You can also look and see, right, this prefix here, that prefix tells you that this is covalently bonded, right? This is a molecular compound. So we don't need to circle and switch. So when it's molecular, you don't circle and switch. You are just going to look at the prefixes. So there's no prefix in front of phosphorus, so that's just 1 phosphorus. And there's penta in front of bromine, so that means it's Br5. So if it's ionic, like the first one, we needed to write out the ions and circle and switch. If it's molecular, then we don't need to write out ions. We're just going to use our prefixes to tell us how many there are. All right, next one, cobalt-2 nitrate. So cobalt is a metal, and nitrate is a polyatomic. But the fact that cobalt's a metal, that tells us that this is ionic, right? Which means that, again, we are going to need to circle and switch. So cobalt-2 is telling us that cobalt is a 2+. Okay, that's actually really nice when we have those transition metals because you don't need to go figure out what the charge is. It's telling you in that Roman numeral. So we have cobalt 2+, and then we have nitrate is our polyatomic. So that's NO3-. So make sure you have those polyatomics memorized. You're going to want them. Now we need to circle and switch. So the 2 is going to go to the nitrate, and the imaginary 1 will go to the cobalt. So we'll write this as CO, right, imaginary 1, and then we need 2 of all of the nitrate. So we're going to put the nitrate in parentheses, and the 2 will go on the outside. Okay, so that's cobalt-2 nitrate. And then on the last one, we have nitrogen and oxygen. Okay, so nitrogen is a nonmetal, oxygen's a nonmetal. This is molecular, right? It's covalently bonded. So we're not going to circle and switch. We are just going to use the prefixes. So dinitrogen tells us N2. Pentoxide tells us 5 oxygens. Okay, so again, if it's ionic, need to circle and switch. If it's molecular, just use the prefixes to figure out the formula. So go ahead and complete problems number 24 and 25.